Hi everyone. Today we are focusing on question number 7 from our May-June 2024 mathematics paper 1. This time around I'm just focusing on financial maths only. Okay, let's do it now. Okay, on the first question we are told that 6 years ago Tabo bought a phone for 13,000. The value of the phone depreciated annually according to the reducing balance method. The value of the phone now is 8,375 cents. 8,337.75 cents. Yes. Calculate the annual rates of depreciation. Okay. What do we have? We do have our principal amount. I prefer that whenever I do financial maths, I write down my data or information that I have now. Okay, for my principal amount, I know that this phone was bought at a price of 13,000. However, in future it has lost the value, and its current value right now is 8,337.75. This thing happened for 6 years. We don't know what is our rate of interest. So since this thing is depreciation, there are two formulas to choose from when it comes to depreciation. There are two formulas, one and the other one. A is equal to since they said that we are using reducing balance, we are going to go with this one. This one is for it's a straight line balance. So whenever it's reducing balance or diminishing balance, we use this one. Straight line method, we use this one. So we'll just substitute our data. Since you know that A is equal to P I minus I. My value of A, this thing in future will be worth 8,337.75. It costed Utabo 13,000. We don't know the value of I, but you know that this thing happened for 6 years. This is our main objective. We want to solve for this guy, which is I. So that simply means we must remove everything and be left with I alone on one side, and everything should be on the left hand side. Ne? So the first thing we do is to divide by 13,000. Ne? Divide by 13,000 both sides, then we'll have 8,337.75 all over 13,000 is equal to 1 minus. Then you must put in the sixth root both sides. 6,8,337.75 all over 13,000 is equal to 1 minus I. So now I've removed the exponent 6 by putting the sixth root both sides. Now I can just isolate I. I can bring I on the left hand side and then take everything to be on the right hand side. Uh, 13,000. Then I is equal to, let me punch my calculator, 1 minus the sixth root of 8,337.75. Things are right. I divide by 13,000. Divide by 18,000. I'll get 0.075244538, ne? But for me to find my rate of interest, I just need to take my interest multiplied by 100. My interest is it's this number here. If I multiply it by 100, I will get my rate. So my rate of interest will be 7.14% per annum. Okay. Now let's move to the next question. This is 7.2 rather. 7.2. 7.2, we are told that Eric and Tandy need to save 80,000 to go on a holiday at the end of December 2027. Okay, Tandy decides that she will start saving at the end of January 2025. She will make 36 deposits into the savings account that pays interest at 8.6% per annum compounded monthly. The deposit will be made at the end of each month. Okay, and then let's just write down our information for Tandy. Tandy wants to have 8,000 in the future. This amount of money is the money that Tandy doesn't have now. Tandy want to save and accumulate interest to reach this destination of having 80,000 in the future. So since the money is not present now, we will be using future value. And we are also told that Tandy will be saving okay, we don't know the amount of money that Tandy will be saving every month, but we know that Tandy will do this for 36 payments. And my rate of interest should be 86%. I mean 8.6% per annum compounded monthly. So it's simply 0.086 divided by 12 because it's divided monthly. And whenever you're given the rate of interest, you must change it to I. And how do you change it to I? Firstly, you must take the rate of interest, which is 86%, divided by 100, and then you'll get 0.086, and then take that amount divided by 12, because interest will be calculated monthly, and each year has 12 months. Okay, we are done with Tandy's information. Let's go to Eric now. Let's go to Eric. Yes, Eric also wants to invest and save money to accumulate 80,000 as well. Eric calculates that if if he makes 36 deposits of 1,402.31 cents, this is our X, the monthly installments, in this case the monthly savings, starting at the end of January 2024. He will have enough money to go on holiday or whatever. So we know that Eric has already calculated that if he pays this amount of money for 48 payments, this amount of money will accumulate interest, and he will reach his goal of having 80,000 in December 2027. Now the question says, calculate the difference between the amount that Eric and Sandy will deposit into their respective savings account over the given period. Calculate the difference between the total that Eric and Tandy will deposit into their respective savings account. Okay, the total amount that Eric will deposit, it's simple. Let's just say Eric's total. It's just, we know that he will pay 1,402.31, and he will only do that for 48 payments. So 1,402.31 times 48. So Eric will pay a grand total of 67,310. The other day my learner wanted to kill me because I didn't write the currency. This thing is in rands, guys, ne? Since you're in South Africa, financial maths, whenever you deal with money, you must always write the currency in rands. Okay, so I know that Eric will pay a grand total of this amount of money. So now I just need to find out how much Tandy will pay in total. But I can only do that if I know Tandy's monthly installment. Are we together? Okay, so future value. I'm using future value because Utani doesn't have this money now. She wants to save and have that money in future. So 80,000 is our goal. It's not what we have now. So it will be 80,000. I don't know this guy, but I know that here I have 0.086 over 12. Here I have 36 payments, and then I have 0.086 over 12. For me to find the value of X, I just need to say 80,000 multiplied by 0.086 all divided by 12 all over 1 plus 0.086 all divided by 12 and raised to the power. Let me punch my calculator. 80, 1, 2, 3 multiplied by 0.086 over 12 divide by 1 plus 0.086 over 12 all raised to the power 36 minus 1. So I find out that Tandy will be paying 1,955 every month, 0.78 cents. 0.78 cents. So the total that Uthandi will pay, Thandi's total is equal to 1,955.78 multiplied by 36, since Uthandi will pay this thing in 36 payments. 1,955.78 multiplied by 36. Uthandi will pay a grand total of 70,408,000.08. So they wanted us to find the difference. So the difference in their total payments, since Uthandi is paying more money, I'll just take her money and subtract it to the one being paid by Eric, minus Eric paid 67,310.88. 67,310.88. So the difference in the total money that will be paid is 3,097.20. What kind of a maths teacher is this? Doesn't know how to read numbers. Okay, let's go. On the last question, we are told that Ulisibana was granted a loan of 250,000. The rate of interest for the loan is 9% per annum compounded monthly. Lisibana will make monthly payments of 5,500 starting exactly 4 months after the loan was granted. How many payments will Lisibana make to settle the loan? Okay, here if you draw your timeline here, you'll have T0. This is when Lisibana received the loan of 225,000. Okay, we don't know how long will it take her to settle the loan, but all we know that at the end of the 4th month, that's when Ulisibana will start paying. So that means she has missed 3 payments, because she was supposed to pay at the end of the 1st month, and at the end of the 2nd month, at the end of the 3rd month. She didn't pay for those 3 months, but she chose to pay at the end of the 4th month. Are we together? So we are being asked, in how many payments will Lisibana make to settle the loan? So firstly, all we need to do is that we can't take this amount as the value of the loan. Why am I saying that? Because as Lisibana missed payments, the value of the loan will accumulate interest. The debt will never be patiently waiting for her. It will never do that. Are we together? So for deferred annuities, just know that whenever you miss payments, the loan will accumulate interest. Okay, so firstly, I know that this value of the loan needs to accumulate interest for 3 months. I know initially it was 225 plus 0.086 over 12. Lisibana only missed 3 payments. So here I'll get 1 plus 0.086 over 1 2 225 1 2 3 1 plus 0.086. Okay, so I can see I'm making a mistake. I'm taking the previous interest of 8.6%, the one of Utandi. Okay, the rate of it. I wanna, guys, writing data is important. My interest is 0.09 over 12. My X is 5,500. My present value, the new value of the loan, is the one that I'm calculating now. Whenever I punch this on my calculator, I get 230,156 cents. So this would be my value of the loan, because Utandi has omitted some of the payments, so the loan will accumulate interest. The bank will never understand her situation, unfortunately. So I want to know, how many payments will Utandi make? Since I'm dealing with the loan, the value of the loan, you are given the money now. The amount is present right now. Hence, you are using present value. So say PV is equal to X 1 minus together. Okay, I'll then substitute. Here I'll have 230,100. Now this teacher must be bent. 1 minus 1 plus 0.09 over 1 2. Let me fix this mistake here as well, because I used the previous interest rate. I want to know the value of n. Here it's 0.09 over 1 2. I actually know the value of x. Why didn't I substitute? The value of x is 5,500. Okay, now I know that I just need to remove this denominator by multiplying it to the other side. Multiply by 0.09 over 12, and then I will have to divide by 5,500, and then I'll be only left with the brackets. Now, so moving forward, I just need to isolate the brackets with the unknown. So I'll have 1 plus 0.09 over 12. Then I'll have 1 minus 230,100 multiplied by 0.09 over 12. This thing is divided by 5,500. Then I need to introduce logarithms. uh guys, I'm still working with the original values because I'm avoiding to work with huge decimal numbers because I think I might get confused. And what if I press the calculator wrong right now? That means I'll be continuing moving with an incorrect answer. Okay, we are solving for n. N is at the exponent, ne? The rules of solving exponents, if you can't make bases to be the same, just introduce logarithms both sides. So I'll have a log the log of 1 minus 23,000. Let me just write the number and stop saying it. Point 0.56 multiplied by 0.09 over 12. And then now I can therefore find my answer. Let me just write it as positive. 1 plus 0 oops, excuse me, sorry about that. I have one. I'm trying to punch a calculator to find the answer. 230100.56 times 0.09 all over 12 divided by 55. I'll get 50.39 50.39437.497. This thing simply means, guys, since I didn't get an integer value, this thing simply means that I will have 50 equal payments of 5,500, and then the 51st payment will be just a small amount of money to settle the account. That's why I'm getting decimals. Okay, guys, yes, it's important for you to substitute everything from the formula, because there are marks for that. Example here, you'll get a mark for doing this and writing the interest value. So already by just substituting you have 3 marks. However, just to avoid making mistakes, just know that to find n whenever you're dealing with loans, n is equal to a negative open bracket is log of 1 minus the present value multiplied by interest all over the installment, and then the base is 1 plus I. If you can just punch these things with calculator, you'll always get your n whenever you're dealing with loans or present value. This is how you find your n. Just to avoid mistakes, please keep this in mind. Just substitute everything here. you'll get your N. Yeah, I hope guys you enjoyed the video and it was productive. Please guys, subscribe, tell your friends, tell your family, and tell them to tell the others ukuthi kumele uyibone maths. Bye guys.